All right. Well, let's dive into some pretty heady stuff today. The nature of time. You know that classic thought experiment about stepping into a river? Can you ever really step into the same river twice? That's Heraclitus right there. And it leads us straight to our topic, time, becoming, and existence. We're going to be looking at this through the lens of modern physics, which, as you know, can really shake up our philosophical assumptions.
Absolutely. It's amazing how a question from ancient Greece can still resonate so strongly, especially when we consider how modern physics has complicated our understanding of time.
Exactly. For this deep dive, you sent over some fascinating philosophical reflections on time, as well as excerpts from the Stanford Encyclopedia of Philosophy's entry on being and becoming in modern physics, like a crash course in the metaphysics of time with a physics twist. So for you, a philosopher grappling with these age-old questions, we're going to see how our modern understanding of the universe forces us to rethink some pretty basic concepts. Like, what does now even mean? What does it mean for something to become? And can we even talk about existence in a straightforward way anymore?
All fantastic questions. And I think you'll find that physics doesn't give us easy answers. In fact, it often raises more questions than it answers.
Okay, so before we get into the mind-bending world of relativity, let's quickly recap the three main philosophical stances on time. You're probably familiar with these, but it's good to lay the groundwork. First up, we've got presentism. The idea here is that only the present moment truly exists. The past is gone. The future hasn't happened yet. It's all about the now.
Presentism is appealing in its simplicity. But, as you know, it runs into problems when we consider the asymmetry between past and future. Why can we know about the past, but not the future? Why can we affect the future, but not the past? These asymmetries suggest that time might be more complex than just a series of fleeting nows.
Exactly. Which brings us to eternalism.
Hmm.
Here, all points in time are equally real, past, present, future, all laid out like a giant, unchanging block.
Eternalism has a certain elegance to it, I think. It solves the problem of those asymmetries by essentially saying they're just illusions of our perspective. But it raises other questions. Does time really flow in this view? And if it doesn't, how do we account for our experience of time passing?
Right, so both presentism and eternalism have their strengths and weaknesses. That's why we have possibilism, which tries to find a middle ground.
Possibilism suggests that the past is fixed, the present is the point of becoming, and the future is open, full of possibilities. It captures our intuition that the past is unchangeable, while the future is yet to be determined.
This seemed to align with how we typically experience time, right? But of course, even possibilism leaves us with some tricky questions. If the present is where things become real, what does that process of becoming actually entail?
Exactly. And how do we reconcile this notion of becoming with a scientific worldview where everything seems to be governed by deterministic laws?
Feels like every time we try to define time, we end up with more questions. Speaking of tricky questions, we have to talk about McTaggart. Now, he famously argued that time is actually unreal. I know it sounds crazy, but his argument is really clever. And it forces us to think carefully about what we mean when we talk about time.
McTaggart's argument is based on the idea that there are two fundamentally different ways to describe time. He calls these the A series and the B series.
Okay, break it down for me. What's the A series all about?
The A series is all about the flow of time. It's how we experience time as a constant passage, with events moving from the future through the present and into the past. Think of it like a river, always flowing and changing.
All right, I'm picturing it. So if the A series is the flow, what about the B series?
The B series is a static way of describing time. It simply orders events based on their temporal relations to each other. Event A happened before event B, event C is simultaneous with event D, and so on. There's no sense of flow or passage in the B series, just a fixed, unchanging order of events.
It's interesting how these two descriptions, the flowing A series and the static B series, both seem to capture something essential about how we understand time. But McTaggart's point is that they actually contradict each other, right?
That's the heart of his argument. He argues that the A series, with its ever-changing designations of past, present, and future, leads to a contradiction. If an event is in the future, it can't also be in the present or the past. But in the A series, every event must eventually occupy all three positions. This, according to McTaggart, implies that the A series, and therefore time itself, is unreal.
Wow. Okay, so is he basically saying that because we can't pin down an event as being only past, present, or future, time itself is an illusion?
That's a good summary. But before we get too carried away with the idea that time is an illusion, some philosophers have proposed that this apparent contradiction arises from a misunderstanding of language.
Oh, So how does language play a role in all of this?
The key is the verb to be. We use it in many different ways, and those different uses can lead to confusion. Compare the sentences, it is raining, and 7 is a prime number. The first sentence uses is in a tensed way, referring to a specific point in time. The second sentence uses is in a tenseless way, expressing a timeless truth.
So the argument is that maybe McTaggart's problem arises because he doesn't distinguish between these different uses of to be.
Exactly. Maybe the real debate about time isn't about time itself, but about the language we use to talk about it. But even if we sidestep McTaggart's challenge, we still need to confront how these different views of time mesh with our best scientific theories.
And that's where Newtonian spacetime comes in, right?
Mhm.
Newton's universe, with its absolute time ticking away in the background, seems to fit pretty well with the classical views of time we've been discussing.
Yes, Newtonian spacetime provides a framework where both eternalism and presentism can seem quite plausible.
Eternalism makes sense because Newtonian time is like a fixed backdrop, with all events existing simultaneously along this unchanging timeline. And presentism, even though it focuses on the present moment, still relies on this idea of a universal now that everyone agrees on.
Precisely. But, as we'll see, this neat picture of time gets thoroughly shaken up when we enter the world of Einstein and his theory of relativity.
Okay, so we've set the stage with the classical views of time and how they fit, at least superficially, with Newton's picture of the universe. But now let's step into Einstein's world. Relativity. This is where things get really interesting and, to be honest, a little mind-bending.
You're not kidding. Relativity completely revolutionized our understanding of time, and its implications for philosophy are profound.
I remember when I first encountered relativity, time dilation, length contraction, all those bizarre consequences. It was a real struggle to wrap my head around it.
It's a challenge for everyone, even for seasoned physicists. One of the most radical shifts introduced by special relativity is the idea that there is no absolute now.
Wait, what? You mean that whole concept of a universal present moment, the one that seemed to work so well with both eternalism and presentism, is just an illusion?
It's not so much an illusion as a simplification that works well at low speeds and in weak gravitational fields. But when you start approaching the speed of light, things get much weirder.
Okay, so how does this relativity of simultaneity actually work? Give me an example.
Imagine two events happening at different locations in space. In Newtonian physics, we could say whether those events happened at the same time, regardless of who's observing them. But in special relativity, whether those events are simultaneous depends on the observer's frame of reference. Two observers moving at different velocities will disagree about which event happens at the same time.
So what might be now for me could be in the past or future for someone else who's moving relative to me.
Precisely. And this has some pretty wild consequences for those classical views of time we were discussing.
I can see how this throws a wrench into both presentism and possibilism. If there's no absolute present, then how can we say that only the present exists? Or that the present is the dividing line between the fixed past and the open future?
It becomes a very difficult question, and to really see just how strange things get, let's talk about the Andromeda paradox. This one really highlights the weirdness of relativity.
All right, hit me with the Andromeda paradox.
Imagine two people, Alice and Bob, walking past each other. Let's say that at that exact moment, according to Alice's frame of reference, the Andromedians, over 2 million light years away, have already launched a fleet of spaceships heading towards Earth. Their decision to launch is a done deal, fixed in Alice's past.
Okay, so Alice is basically witnessing something that happened millions of years ago relative to her now.
Exactly. But here's the kicker. According to Bob's frame of reference, who's moving in the opposite direction to Alice, the Andromedians haven't made the decision to launch yet. That event is still in his future.
Hold on. So for Alice, it's already happened. But for Bob, it's still to come. How is that even possible?
That's the paradox. If we take Alice's perspective as true, that the Andromedians have definitely launched their fleet, does that mean that Bob's future, including the Andromedians' decision, is also already fixed?
It seems like it would have to be, right? If the past is fixed, then shouldn't the future also be fixed?
That's the line of thinking that leads to a concept called chronogeometrical fatalism, the idea that the future is just as determined as the past.
That's a pretty unsettling thought. Free will goes out the window, and the whole notion of becoming seems kind of pointless if everything's already predetermined.
Absolutely. It challenges some of our most fundamental intuitions about time and our place in the universe. But before we descend into a deterministic abyss, we need to consider how the structure of space-time itself might offer a way out of this paradox.
Okay, so what's the escape hatch here?
The key is to understand the concept of light cones. They're crucial for understanding the causal structure of spacetime.
I remember encountering light cones in my physics classes, but to be honest, I never really grasped their philosophical significance.
Well, light cones are essentially a way of visualizing which events in spacetime can causally influence each other. Imagine dropping a pebble into a pond. The ripples that spread out represent the expanding light cone of that event.
Okay, so anything inside the light cone could be affected by the initial pebble drop because information can travel to those points at the speed of light or slower.
Precisely. But anything outside the light cone is causally disconnected. No signal or information can travel faster than light, so those events can't influence each other.
So how does this relate to the Andromeda paradox?
The events in Alice's past that involve the Andromedians are space-like separated from the events in Bob's now. They're outside of his light cone. This means there's no causal connection between them. Even though those events are in Alice's past, they can't actually influence what happens in Bob's future.
So the light cone structure of spacetime prevents this kind of fatalistic scenario where the past rigidly determines the future.
Exactly. It preserves a degree of causal openness. Even though different observers might disagree about the timing of events, the causal order of events is preserved within each observer's light cone.
That's a relief. But I'm still struggling with how we're supposed to think about becoming in this relativistic context. If there's no absolute present, how do we make sense of the feeling that time is flowing, that things are constantly becoming?
That's the million-dollar question. It's one of the biggest challenges for philosophy of time in a relativistic universe, and it pushes us to reconsider whether our intuitive notions of a flowing time are actually fundamental features of reality.
So maybe we need to rethink our whole approach to time. Instead of clinging to this idea of a universal now sweeping across the cosmos, maybe we need to focus on a more localized understanding of time.
That's one promising direction. Instead of global notions of time like simultaneity, maybe we need to focus on local notions like proper time.
All right, proper time. It sounds very technical. Give me the rundown.
Proper time is essentially the time measured by an ideal clock that's traveling along a specific path through spacetime. Think of it as the time experienced by an object as it moves through the universe.
So even though different observers might disagree about which events are simultaneous, they will all agree on the proper time that's elapsed along a particular object's world line.
Exactly. And here's what's really fascinating. Proper time is an invariant quantity. It's the same for all observers, regardless of their relative motion.
Okay, so even in this crazy relativistic world where time is relative, there's still something about time that's absolute and unchanging.
That's right. And this invariance of proper time provides a possible way to think about becoming in a local sense. As an object travels along its world line, its proper time advances. And in a way, it becomes with each tick of its internal clock.
So maybe instead of trying to find a universal now that applies to everyone, everywhere, we should focus on this idea of local becoming, with each object experiencing its own unique flow of time along its world line.
It's definitely a promising avenue to explore. It allows us to incorporate some aspects of our experience of time passing while still acknowledging the relativistic nature of time.
This is really making me rethink what it means for something to exist in time. But if we're shifting our focus to local notions of time, what happens to the concept of the present? Can we still talk about a now in a meaningful way if there's no global present?
That's where things get really interesting. And that's what we'll delve into in the final part of our deep dive. There are some fascinating attempts to define the present in a relativistic context, but as you'll see, they come with their own set of challenges.
Okay, so we've gone from those classical views of time all the way to relativity, and now we're left with this puzzle. How do we even talk about the present when there's no absolute now? I'm ready for some answers, or at least some more questions.
Well, you're in luck because philosophers haven't given up on the present quite yet. There are a couple ways to try and rescue this concept, even within the framework of relativity. But as you might expect, each one comes with its own set of challenges.
Okay, I'm all ears. Lay those solutions on me, along with their philosophical baggage.
All right, so one approach, and this one was championed by Rob, Stein, and Deeks, is to define the present as simply a single space-time point, a now point. Each point in space-time represents its own unique now. It's a radically localized view of the present.
So no duration at all to the present, just a single infinitesimal point in space-time. That seems pretty hard to reconcile with our everyday experience.
It does. After all, our experience of the present definitely feels like it extends beyond a single instant. We have this specious present, this short window of time where we perceive events as happening now. So how can a point-like present account for that?
Right. If my present is just a point, how can I even have a conversation or experience a melody? Things which clearly unfold over time feels like something's missing.
That's where the concept of the causal diamond comes in. It's another way to think about the present relativistically, and it might resonate more with our experience of the specious present.
Causal diamond. Okay, now you've piqued my interest.
Picture a specific event, something simple, like snapping your fingers. The causal diamond for that event is the region of spacetime formed by the intersection of two light cones, the future light cone of the start of the snap and the past light cone of the end of the snap.
Okay, let me visualize this. So the causal diamond is like this little bubble of space-time that contains everything that could have causally influenced the finger snap, as well as everything that the snap could causally influence, the sphere of causal relevance for that event.
Exactly. And because the specious present, that window of now that we experience, has a finite duration, it's tempting to think of the present as this causal diamond rather than a single point.
So instead of my present being this infinitesimal now point, it's actually this whole diamond-shaped region of space-time, encompassing a few seconds, containing all the events that I can directly interact with. That actually feels a lot more intuitive.
It does, doesn't it? It seems to align better with the way we perceive time, like time having some thickness to it. But even with the causal diamond, we're still left with some tricky philosophical questions. How do we determine the boundaries of the specious present? Is it objectively defined, or is it subjective, varying from person to person?
And if the present is this causal diamond, does that mean it's constantly shifting and changing as we move through space-time? Does everyone have their own unique present diamond? It feels like we're just pushing the problem back a step.
You're getting right to the heart of it. The concept of the present, even in these relativistic interpretations, remains elusive. It seems that relativity, while giving us an incredibly accurate picture of the physical universe, leaves us with more questions than answers when it comes to our experience of time and our place within it.
I'm sensing a theme here. Seems like the more we learn about time from physics, the more mysterious it becomes from a philosophical standpoint.
That's the beauty of it, really. Physics can illuminate the structure of the universe, but it's philosophy that grapples with the meaning, the implications of that structure.
Absolutely. So for you as a philosopher delving into these questions, I think the takeaway here is that relativity doesn't invalidate the philosophical questions about time. It just makes them even more fascinating and complex.
I completely agree. Relativity forces us to reconsider what we mean by now, becoming, and existence, but it doesn't provide any easy answers.
It's like physics has given us this incredible map of reality. But it's up to us as philosophers to explore the terrain, to figure out what it all means.
Beautifully put, and one of the most exciting aspects of this exploration is that it's not just about reinterpreting old ideas, it's about generating entirely new questions. If time is truly this relative and dynamic entity, what does that mean for concepts like free will, causality, the meaning of life?
Those are questions for another deep dive, I think. But I have a feeling that exploring those questions will lead us down even more rabbit holes.
I wouldn't have it any other way. The mysteries of time, I suspect, will keep philosophers and physicists busy for a very long time.
And on that note, we'll leave our listeners to ponder the implications of relativity for their own understanding of time and existence. Thanks for joining us on this deep dive into the ever-shifting river of time.